Now, let's do another example on theorem number 1 and its converse. In triangle ABC, we have BD over DA, BD over DA is equals to 1 over 3. So BD over DA, it's 1 over 3. And ED is parallel to CA, as you can see. This is parallel to that. And HD is parallel to EA. HD is parallel to AA. So this is parallel to that, as you can see. Now, we are told to find BH over HE. BH over HE. Now, BH over HE is equals to BD over DA. Therefore, it means that this over this is equals to this over that. Why is that? Because in triangle AEB, this side is parallel to this side. So it means that HD is drawn parallel to one side. Therefore, it's going to divide the other two sides in the same ratio. This side and this side are going to be divided in the same ratio, since this side is parallel to the third side. Theorem number 1. BH over HE is equals to BD over DA, which is 1 over 3. Reason? Because BD over DA, it's 1 over 3. Since they are equal, why is that? It is because HD is a parallel to EA in triangle AEB. B. Now they want us to find B, and B is BE over EC. BE over EC, it's also equals to BD over DA. Why? Because this side is drawn parallel to this side in triangle ABC. Therefore, this side is parallel to this side. Therefore, this line is going to divide this side and this side in the same ratio. Therefore, BE over EC is equals to BD over DA, which is equals to 1 over 3. Why is it that? It is because ED is parallel to CA in triangle ABC. Therefore, in triangle ABC, this side is parallel to this side. So this side is drawn parallel to one side of a triangle. It will divide the other two sides in the same ratio. This over that is equals to this over that. That is why we have that there. Reason? It is because DE is parallel to CA in triangle ABC. With this one, we say this over that is equals to this over that, because this is parallel to that in triangle AEB. That is why we have that. C, they say to us, we must find BH over HC. We have to find BH over HC. Now, for us to do that, we're going to let BH to be equals to X, right? And HE to be equals to 3X. Why is that? It is because we are told that since we have got that BH over HE is equals to BD over DA is equals to 1 over 3, so it means that this is 1 over 3. Therefore, BH, we're going to let it to be X. HE, we're going to let it to be 3X. Now, since here I've got X, here I've got 3X, it means that then BE is equals to 4X, because X plus 3X, it gives BE, which is BE is equals to 4X. Now, we know that BE is equals to 4X. We know that this is 4X. So we need to know what is that. So obviously, if I've got BH over HE to be equals to 1 over 3, BH over HE to be equals to 1 over 3, then we've just said that this is X. We've just said that this is 3X, as I have done there. Therefore, it means that BE, this is BE. Now, since our BE is 4X, so what have we done to BH there? It means that you have multiplied X by 4 over, because BE over EC, it was 1 over 3. Therefore, it means that since we know that this is 4X, so we want to know what must this be. So what have we done there? We've multiplied by 4. That is why we got 4X there. What have we done? It means that we must also multiply by 4 there, so that we can get 12X. Therefore, it means that, therefore, EC is equals to 12X. I'm not sure if I can repeat that. If this is X, and this is 3X, and we know that this over that, it's 1 over 3, which is X over 3, so this is also equals to, this is also equals to BE over EC. BE over EC, which is that. Therefore, our BE is 4x in this case. Now, since we now have our EC, we also have our HE. Therefore, this is 12 plus that for us to get HC. Therefore, HC is equals to 12 plus 3, which is 15x. HC. Therefore, BH over HC, we know our BH, we said it's x, over our HC, we said it's 15x. Therefore, obviously, this cancels with that. We are left with 1 over 15. Therefore, it means that BH over HC is 1 over 15. Now, we can also be told to find HE. HE over BC. Our HE is 3x. Therefore, this is 12 plus 3, which is 15x, plus x, which is 6x. Therefore, 16x. Therefore, D, I'm just going to write D here. Therefore, D, we're going to say BC is equals to 16x. Therefore, HE over BC is equals to, what is HE? HE is 3x over, what is BC? We've just said 12 plus 3, which is 15, plus x, which is 16x. Therefore, this is the same as 3 over 16. So it is easier if we are given one ratio, so that we can let that, since we know that BD over DA, BD over DA is the same as BH over HE. Therefore, we can let BH to be equals to 3x, because that's what they were looking for, BH over HC. Therefore, BH to be x, since we know BH over EH, BH over HE is 1 over 3. Then we're going to let BH to be x, HE to be 3x. Then we can get whatever ratio that they are looking for in a problem, as we have done. So with this one, since we know BE, that it is BE over EC, it is 1 over 3. Therefore, since we know that this is 4x, it means that this is 12x. Therefore, HE over BC is equals to 3 over 16. Let's do another example for theorem number 2. We know theorem number 2 that it states that if two triangles are equiangular, then they are similar. Now we are told to solve for the variables in triangle PQS and triangle KLM. It means that we need to solve for x and y in these triangles. And for us to solve for x and y, we need to first prove that the two triangles are similar. Once we prove that the two triangles are similar, then we can use ratio. We can set up our ratios of the sides, then solve for what we are looking for. Now first let's prove that the two triangles are similar. In triangle PQS and triangle KLM, angle Q is equals to angle L risen. We're given that. Angle S is equals to angle M even here we can say equals to 48 degrees given. Angle S is equals to angle M, which is equals to 50 degrees. We are still given. Therefore, we know that if two interior angles of one triangle are equals to two interior angles of another triangle, then the two triangles are similar. Therefore, triangle PQS is similar to triangle KLM, risen equiangular triangle, since the corresponding angles are equal. So it means that also that is going to be equals to that. But we know that if we can find that two interior angles of one triangle equals to two interior angles of another triangle, then we know that the two triangles are equitriangles. We can just shorten it like that. Triangles. Since this triangle is similar to this triangle, since they're equiangular, then we know that we can say KL, therefore KL over PQ is equals to, obviously we are looking for y in this case, that is why we say this over that. Since we've got these two sides, therefore we can say is equals to that, which is LM over QS. And also, since the two are similar, we can also say KM over PS, or over PS, it's fine, which is equals to LM over QS. What's KL? KL, it's Y, over PQ is 3.1, which is equals to LM is 8, over QS is 4. Now we can cross multiply. This times this is 4y Now, this times this, we've just said it, it's 4y. This times that is 24.8. Now we divide by 4, we divide by 4. Y is equals to 6.2. Now we use this to find x. So Km is 6. We are here. This is the same as 6 over PS is x, which is equals to our Lm is 8 over 4. Now, obviously, this times that is 8x. Here I'm going to have 8, this times this is 8x equals to this times this is 24. Divide by 8, divide by 8, our x is 3. Our x is 3 in this case. So if we've just found x to be 3, we just found y to be 6.2. We must first prove that the two triangles are similar. Then we can set up our ratios so that we can solve for what we are looking for. Let's do another example on theorem number 2. Here we are told that DC is a tangent to the circle at C. Now we are told to prove that triangle ACD is similar to triangle CBD. It's similar to triangle CBD. So this triangle, we need to prove that it is similar to this triangle here. Now let's prove that. For us to prove that the two triangles are similar, we can prove that they are equangular. We can prove that the two triangles are equangular by finding two angles which are equal. Now, obviously, in this triangle, we know that this angle is equals to that angle. Therefore, A, we're going to say B angle C D is equals to angle A. We know a chord is making an angle with the tangent. Theorem number 9, part 2. An angle made by the chord and the tangent is equals to the angle in the alternate segment. Therefore, tan chord theorem. Now, angle D is equals to angle D. Because angle D, this angle, is an angle for this triangle. D is also an angle for this triangle. Therefore, D in this triangle is equals to D in this triangle. Therefore, here, reason D is common. Angle D is common. Now, therefore, triangle ACD is similar to triangle CBD. Reason why we're saying that? They're equangular triangles. Since two angles of one triangle equals to two angles of another triangle. Therefore, equitriangles. We've just proved that triangle ACD and triangle CBD are similar since they are equiangular. Now, we are told B to show that DC squared is equals to BD times AD. We are told to show that DC squared is equals to DB times AD or DA, however we prefer. Since we have proved that this triangle is similar to this triangle, we can set up ratios. B. We can set up ratios, and I can see that it has DC squared. So I can start there. DC over, I'm setting up the ratio. And DC, I know it is opposite this angle there. I need to know that this angle and this triangle is equals to what? Now, since this angle and this triangle is equals to this angle and this triangle, and this angle, which is D, is equals to D, this angle and this triangle, which is D, is equals to this angle and this triangle. Now, I know that this angle here, I'm going to use a different color. I know that this angle here is equals to this angle there. So I can see this angle is equals to that angle. This angle is equals to that angle. As you can see, this angle is opposite this side. That is why I wrote DC. This angle is opposite this side. That is why this angle over this side over this side. Since these sides are opposite equal angles, this angle is opposite this side, this angle is opposite this side. Therefore, that is why DC over AD or DA is equals to, I can see they want BD. BD. So this is the side they want. But we have started by DC, and we started in this triangle over this side of this triangle. So even here, I'm going to start in the small triangle. And BD is opposite this angle in green. Therefore, this angle in green is opposite BD. And we need to start with the side with the small triangle, which is equals to DB, which is equals to DB over. We can see that this angle is subtended by this side. We must look for the side which is subtended by this angle and this triangle. Therefore, in this triangle, this angle is opposite this side, which is DC. Oh, so it means that since this angle is subtended by this, we're going to say since and this side we started in this triangle, we ended in that triangle for DA. Even here, we're going to start in this triangle, but we'll look at this, the side opposite that, which is BD, which is equals to DB over, obviously, this side for this triangle is opposite DC or CD. right? DC. Therefore, this side over this side, since they're subtended by equal angles, is equals to this side over this side. Since they're subtended by equal angle, that is why we have that there. Why are we saying that? Why are we setting up the sides to be in the same proportion? It is because we know that triangle ACD is similar to triangle BDC. That's why if the two triangles are similar, then we know the sides are in the same proportion. Now, we can cross multiply this times this, DC squared. This times this, we're going to have obviously a dB times this is dB times dA. dB times dA, which is that. So it means that for us to prove this, we need to first show that these two triangles and this triangle are similar. Then you highlight the angles like I've highlighted so that you can be able to set up your ratio, because the side opposite this angle, which is that, obviously this side is opposite that, and these two angles are equal. That is why we have this over that is equals to this over that, because now we can see that this side angle and this angle are equal, and this angle is subtended by that, and this angle is subtended by that. Then obviously, if we started in this triangle this side, we also need to start in this triangle for that side. That is why in this triangle, this angle is opposite there. That is why we've got BD over this angle, which is in this triangle, it's subtended by that. That is why we've got DC. Therefore, we can cross multiply and prove that.